You know, from the photos on your phone to the way you search the web, there's this powerful form of artificial intelligence called deep learning. And it's quietly shaping our entire world. But how does it actually work, right? How can a machine learn to see or speak or even understand things? So let's pull back the curtain and really dig into how this whole thing works.
To really get why deep learning was such a game changer, we have to start with a problem that stumped AI researchers for decades. And it's a challenge that, honestly, seems incredibly simple to you and me. But for a computer, it's a massive, massive hurdle.
All right, so just look at these two animals. How in the world would you teach a computer to tell them apart? And I mean, really think about it. You can't just program a rule like, one has pointier ears, or look for a different snout. The machine has to learn all those subtle differences for itself, starting from nothing but a bunch of raw pixels.
Okay, and here's where it gets really tricky for a computer. For the machine, this semioid dog isn't a dog at all. It's just a grid of numbers, almost identical to a picture of a white wolf in a similar pose. And this creates this classic AI challenge. The machine has to be sensitive enough to notice the teeny tiny differences that actually matter, like the subtle curve of the snout or the exact shape of the ears, while also being tough enough to completely ignore all the irrelevant stuff, like the lighting, the camera angle, or what's in the background.
So if simple rules just don't work, how did we even try to solve this problem before deep learning came along? Well, the answer involved a ton of human effort. In fact, it created this massive bottleneck that held AI back for years.
On the left here, you can see the old way, what we call conventional machine learning. You had human experts who had to painstakingly, and I mean painstakingly, hand code all the important features. They'd basically tell the machine, hey, look for this specific ear shape, or measure the snout length, or analyze this fur texture. But on the right, you see deep learning, which completely flips the script. You just feed it the raw data, thousands and thousands of labeled pictures of dogs and wolves, and it discovers those critical features all on its own.
And this quote just captures that old problem perfectly. Every single new task, whether it was identifying cats or cars or even things in medical scans, it required a whole team of experts to start all over again from scratch. It was incredibly slow, it was expensive, and it just didn't scale. Clearly, we needed a much, much better way.
And that better way? Well, that's the central idea behind deep learning. Instead of having one giant, super complex step, the whole system learns in a hierarchy of really simple layers, one on top of the other.
This whole concept is called representation learning. The machine automatically figures out the best way to represent the data to solve the problem. So deep learning methods are really just a form of representation learning that uses many, many layers stacked on top of each other, building up from really simple concepts to much more abstract ones. To really get it, let's actually visualize how the machine sees that image of a dog, layer by layer.
So it all starts at the absolute most basic level. The machine doesn't see a dog or fur or anything like that. It just sees a grid of numbers, each one representing a pixel's color and brightness. This is layer 0, just the raw input. Now, from that sea of pixels, the very first layer of the network learns to identify the most primitive features you can imagine. It's not looking for eyes or ears yet, not even close. It's just finding really simple stuff like horizontal edges, vertical edges, corners, and little patches of light and dark.
Then, things get interesting. The next layer takes those simple edges as its input, and it learns how to combine them. It starts to figure out that, hey, a certain arrangement of these curves and lines makes an eye, and a different arrangement makes a nose. It's starting to see the actual parts of the whole picture. And this process just keeps going, layer after layer. The next layers assemble those parts, the eyes, the nose, the ears, into a face, and then that face into a complete object. By building this deep hierarchy of features, the system learns this incredibly rich, abstract concept of what a samoid really is, which finally allows it to tell it apart from a wolf.
But here's the absolute most important part of this whole thing. A human doesn't design these layers. The machine literally teaches itself, learning from all that data through a process of trial and error on a scale that is just mind-boggling. So here's basically how it works. The network is shown a picture that a human has already labeled. Let's say this one's a wolf. The network then makes a guess. Maybe it says, I'm 70% sure that's a wolf. It then compares its guess to the correct answer and measures how wrong it was. Based on that error, it goes back and slightly adjusts millions of tiny internal parameters, you can just think of them as knobs, to make a slightly better guess next time. And then it just repeats this process, millions upon millions of times, getting a tiny bit smarter with every single example it sees.
And the engine that makes all of this possible is a brilliant algorithm called backpropagation. It's really the mathematical heart of deep learning. It's the procedure that calculates exactly which direction to turn each one of those millions of knobs to get the error rate to go down. It is the mechanism that drives the learning.
So with this incredibly powerful approach to learning, what have we actually achieved? Well, the answer is nothing short of a full-blown revolution in artificial intelligence. Deep learning has just shattered records in fields that had resisted the best attempts of AI for decades. I mean, it's given us superhuman image and speech recognition. It powers that instant language translation you use on your phone. But it's also revolutionizing science itself, from predicting how new drug molecules will behave, all the way to helping scientists analyze these massive data sets from particle accelerators.
And this is where you really see the magic. A deep learning system wasn't just trained to spit out labels like people or market. It looked at this image, a collection of pixels it had never seen before in its life, and generated a full, coherent sentence. A group of people shopping at an outdoor market. It's not just recognizing objects, it's starting to understand the scene.
So where does this incredible journey of machine learning go from here? Well, the next frontier is already in sight, and believe me, it's even more ambitious.